Good morning. We are going to see a topic regression equation in the course Mathematics and Statistical Computation. Regression, a study of measuring the relationship between associated with the variables wherein one variable is dependent on another independent variable. This is called as a regression. It is developed by Sir Francis Galton in the year 1877. Here we used to measure the relationship between the height of the parents and their children. Regression analysis is a statistical tool to study the nature and extent of a functional relationship between two or more variables. Uses of regression analysis: it provides estimates of values of the dependent variable from values of an independent variables. It is used to obtain a measure of the error involved in using the regression line as a basis for estimation. With the help of regression analysis, we can obtain a measure of degree of association or correlation that exists between the two variables. Regression lines and regression equation. Regression line of y on x, this line gives the parabola value y for any value of x. My formula is x, y minus y bar is equal to byx, x minus x bar. Regression equation x on y is x minus x bar equal to bxy, y minus y bar. Regression coefficient is denoted by the value as r. Regression coefficient is also denoted as bxy, and for y on x is byx. Formula for calculating a regression correlations using xy and arithmetic mean. There are three formulas. Bxy is equal to r sigma x divided by sigma y. If the standard deviation and the correlation coefficient is given, then we can go with the first formula. If the number of items and the x and y values are given, then we can go with the second formula. When the deviations are taken from the arithmetic values, then we can go with the third formula. My first problem is find the two regression equation. Xy values are given. If we add the x values, we will get the value of summation x, that is 120. If we add the y values, we will get the values of summation y values. If we square it and add the values of x, we will get the summation x square. If we square the values of y and all together, the sum will give you the summation y square. And if we multiply the xy and add it, we will get the values 2542. Now my normal equation is summation x equal to na plus b into summation y, and summation xy equal to a summation y plus b summation y square. If I substitute all my values in the above equation, I will get the equation 1 and 2. It is a simultaneous linear equation. If I solve it by elimination method, I want to multiply my first equation by 20. If I multiply it, I will get the a value as cancel. A value will get cancelled. If I multiply it by 20, I will get the a value as cancelled, and my value is minus 142 equal to minus 172b. If I divided it, I will get the b value as 0.8256. Similarly, we can calculate the a value by substituting this b value in either first or second equation. I am having my first equation, and if I substitute my b value, if I solve it, I will get the value as 8a is equal to minus 12. But I need my a value alone, so I bring it 8 to my denominator. Then my a value will be minus 1.5. If I substitute in my regression equation, I will get my regression equation as x equal to minus 1.5 plus 0.8256y. Regression equation y on x, the same format, but instead of summation x, I am having summation y. If I solve it by multiplying and cancel it, I will get the value of b alone, that is 1.127. Similarly, I am going to substitute that b value in equation number 3 or 4. If I substitute my b value, I will get the a value as 3.095. My general equation is y is equal to a plus bx. My a value is 3.095 and my b value is 1.127. If I substitute in my required equation, I will get my equation as y is equal to 3.095 plus 1.127x. This is how we have to calculate our regression equation for both x on y and y on x. The formula can differ according to our problems. Thank you.